Welcome back to Howard's Math Lessons. So today's video is going to be, it's going to be an extension of an old video, or the last video I uploaded, which was using the official definition of a limit to prove that the derivative of e to the x equals e to the x. Okay? And in that video, we basically proved three statements. And if you want to see the proofs for these statements, you can go back and look at that video. But the first thing we proved was that the limit as h approaches 0 of the natural log of 1 plus h over h equals 1. The second thing we proved is that the limit as m approaches 0 for some number m, em minus 1 over m for this function is also equal to 1. And then we use that to prove that the derivative of e to the x equals e to the x. And if you want to see the official proofs of the limits, just go back to the video I uploaded a couple weeks ago. But today, what we're going to do is we're going to actually find the derivative of the natural log of x using the official definition of a limit, right? So I know if you already learned differentiation, you could probably do it in a much easier way, but we're just using the official definition of a derivative, which is, what is it? It's limit as, so f derivative of x equals f of x plus h minus f of x over h. Right, we're just going to use this to prove that the derivative of the natural log of x equals 1 over x, and it's actually a really elegant proof. So yeah, so the first thing we're going to do is we're going to use the official definition of a limit. So the first thing, so we're going to write the derivative of the natural log of x equals, so we're going to use this format as limit h approaches 0 of, natural log of x plus h minus natural log of x over over h. And yeah, so that's the derivative of natural log of x. The next thing to prove is that we can actually move this 1 over h, or this h, into this part. We can actually combine all of these into one natural logarithm. So first thing we do is, if you remember your log laws, log of x minus log of y equals log of x over y. And if we look at this situation, the natural log is just log e. So this law applies to the situation. So we can do, I've got the limit as h approaches 0 of the natural log of x plus h over x, and then over h. And if you also remember, we're going to do another log law now. Log of x, so a log of x equals log of x to the power of a. Okay? And we can rewrite this so it becomes 1 over h times the natural log of x plus h over x, right? And then we can actually put this as a power. So limit as h approaches 0, natural log of x plus h over x, all to the power of 1 to h, sorry. And then we can cancel out some like terms, because we're going to look back at what we know, and we see that this form, looks very similar to this one we have right here, right? And actually I made a mistake here. So we're not going to bring the 1 over h into the exponent. So that's my bad. But yeah, so we see that if these x's cancel out, then we have 1 plus h over x, 1 plus h over x as a term, and we have this fact here, natural log of 1 plus h over h equals 1. So we can find some way to relate this to this, then we can solve the problem, and we can figure out what the derivative of natural log of x is. So first thing I'm going to do is I'm going to cancel. So this, if you distribute, equals x over x plus h over x, and x over x is just 1. So let's turn this into a 1, and this is divided by h. Right? And next, what I'm going to do is I'm going to multiply the top and the bottom by 1 over x. Because what I'm trying to do is I'm trying to make this as similar to this as possible. And the only thing that's different is that this top part is different from the bottom part. So if I can find a way to make sure that this top part is the same as the bottom part, then we can make sure we can make a connection, and we can actually use this, right? This fact, right? So let's see how it's different, how the top part's different from the bottom part. Well, the top part, it has an extra divided by x. So what I can actually do is I can multiply top and bottom by 1 over x, right? This is just 1. I can multiply it by 1. So when I actually do that, it becomes right? And then what we have to do is we see that as limit as h approaches 0. It doesn't matter. That has no effect on what 1 over x is, right? Because 1 over x is just a constant right now, because we're thinking about the graph of h, and h is approaching 0, but that doesn't change x at all. So we can bring out 1 over x times the limit h approaches 0. 1 plus h over h over x. And then what we have to realize is that as h approaches 0, h of x also approaches 0, right? Because if we look at the top, if the top is approaching 0, then the whole fraction approaches 0. So we can change the limit of h approaches 0 to the limit of h of x approaches 0, right? Because these two are the same. As limit as h approaches 0, h of x will approach 0. And if we look at the top, we have all these variables are the same. Thus, we can simplify this part into 1. And that's how we find that the derivative of the natural log of x is equal to 1 over x using the official definition of